Here I've got some sodium hydrogen carbonate on the scupula. I put it into solution and we'll stir it around a bit, and I'm about to place this sodium hydrogen carbonate aqueous into a 5% solution of acetic acid, which is CH3COOH. Sure, it's baking soda and vinegar, but what's the reaction? Well, now it's time to do some reaction chemistry. These replacement reactions, single and double replacement, are when we take chemicals that are ionic in nature, put them in solution, and react them either with another element or compound to get a rearrangement of chemicals on the other side. Okay, here it comes. Watch this. Here's a piece of nickel, and we put it into a solution of silver nitrate. This is AgNO3, Ag positive NO3 together, and it's aqueous because it's in solution. I took an ionic crystal and I dissolved it to make a solution. AQ means aqueous dissolved in water. Okay, now what happens? How do these two chemicals react in solution? What we do is we take this metal, which is nickel, and then we take the silver here and we make them trade places. That's a replacement reaction, but you have to maintain the proper charges when you're recombining to form the products. Watch. When the nickel reacts with the silver nitrate, they change places and the nickel goes with the nitrate. Nickel, however, on your periodic table has a what charge? Nickel is, the most popular charge in nickel is the 2 positive one. So when you're not told which one to use, you always use the one that's more popular, which is the Ni2 positive. But you might not use Ni2 positive, you might use Ni3 positive or Ni positive. You have to be told. But when you're not told, there it is right there, Ni2 positive. But nitrate is one of those polyatomic ions that's a -1 charge. So when these two come together, look at what they form. It's bracket NO3 bracket 2. There's 2 nitrates for every 1 nickel. Now, you need to check a chart called the solubility chart to be able to determine whether or not this is aqueous or whether it comes out as a solid precipitate. Here's what that chart looks like. There's a solubility chart right there. Now, how do you work this? Well, here are some very common ions, cations over here, some anions down here, and if you can match the anion or cation up here with one that falls into this range here, then that says solubility greater than or equal to 0.1 moles per liter, very soluble. That means aqueous. So you'll just put AQ next to that compound. But if any of these compounds match up with anything in here, that means slightly soluble, and you've got yourself a solid. So you put an S. So when you look on that chart, here's the idea. Nothing ever precipitates with nitrate, as you could see. So therefore, nickel and nitrate form a solution. A precipitate is a solid. So this remains AQ, just like this one was AQ. But what goes off by itself now? Well, the silver goes off by itself. Now, how do we write silver when it's by itself? Just AG. Not Ag2, it's not in group 7 or anything like that. All we do is write silver and a solid. And we have no charges left for anything up here. You never write those charges once you got the compounds written down. Now, there's your equation, and it only is requiring you to get it balanced. So, let's do that. 1 nickel here, 1 there. 1 silver there, 1 there. It is easy. It's not done. 1 nitrate here, 2 nitrates. See, I kept the NO3 together. I went 2 NO3s because, you know, NO3 is on the other side too. So balance the whole thing, that whole polyatomic ion together. Don't have to balance the nitrogens separately from the oxygens. It's fine. So take a look. 1 NO3 there, 2 there. You got to put a 2 in front here. Now you got 2 NO3s, but you got 2 AGs. And now the entire equation is balanced 1, 2, 1, 2. Let's do another one.